All right, so if you've ever built an Arduino project, you've probably run into this, that super frustrating lag, right? Where you press a button and nothing happens until some other task is finished. Well, if that sounds familiar, you're in the right place. Today, we are going to unlock the secret to getting that lightning-fast real-time response, and we're going to do it by demystifying the powerful concept of interrupts. So here's how we're going to tackle this. We'll kick things off with a really simple, everyday analogy. Then we'll dive into a common coding problem that causes all that lag. After that, we'll introduce the solution, show you exactly how to code it, and then we'll see the amazing results for ourselves. Okay, so before we get into any of the techie stuff, let's just forget about code for a minute. We're going to start with this super simple analogy, something we've all experienced. So just imagine this. You are completely zoned in on something important. Maybe you're writing a big email, or you're deep into a great book, and then knock, knock, knock. Someone's at the door. Your focus is broken. What do? What's that immediate gut reaction? Right? You don't say, hold on, I'll be there in 200 pages. No way. You pause what you're doing, you go see who's at the door, deal with it, and then you come right back and pick up where you left off. Well, that simple, everyday action, that is exactly how a hardware interrupt works on an Arduino. It's that simple. Okay, now let's take that idea and see how it plays out with some actual electronics. We're going to set up a challenge for our Arduino. We'll give it 2 jobs to do at once and see what happens when we try to code it the normal way. So the goals here seem pretty straightforward, right? Goal number 1, we want a yellow LED to just blink. On, off, with a 1-second delay. That's our main background task. Then, goal number 2, and this is the important part, we want to be able to turn a red LED on or off with a push button. And we want it to be instant.
And here's where things go wrong. What we expect is instant control. But what we actually get is this awful, frustrating lag. You press the button and crickets. Nothing. You literally have to wait for that yellow LED to finish its 1-second cycle before the Arduino even notices you did anything. That's not multitasking, that's just waiting your turn.
So who's the bad guy in this story? Well, it's a function we all know and use, delay function. That one little line, delay 1000, literally tells the Arduino, hey, just stop. Do absolutely nothing for 1 full second. It's what we call blocking code. It basically puts blinders on the processor, so it's completely oblivious to our button press.
So what we really need here is a way to break out of that delay, right? We need our button press to be that knock on the door that gets the Arduino's attention immediately. And that is where our hero comes into the picture. Let's talk about interrupts.
So what is an interrupt? Well, it's pretty much exactly what it sounds like. It's a special kind of signal that tells the microcontroller, hey, stop what you're doing right now, something more important just happened. So it pauses its main task, jumps over to a special little function to handle that urgent event, and when it's done, it goes right back to the main task, exactly where it left off. It's the ultimate knock on the door for your code.
Okay, let's look at the actual code. How do we make this happen? Well, it all comes down to one really powerful function that tells the Arduino 3 things: what to watch, what to do, and when to do it.
The absolute key to this whole thing is a function called attachInterrupt, and you only need to set it up once, right in your void setup section. Think of it like this. When your Arduino first boots up, this line of code hires a permanent watchman and tells them, your only job is to watch this one specific pin and let me know the instant something happens.
Now, this function needs 3 key pieces of information. The first one is the pin. Super simple, right? This is just the physical digital pin you want that watchman to keep an eye on. For our circuit, the button is on digital pin 2, so that's what we tell it.
The second piece of info it needs is the ISR. That stands for Interrupt Service Routine, which sounds way more complicated than it is. It's really just the name of the special function you want the Arduino to run the moment that interrupt happens. It's the what to do part of the instruction. You know, the go answer the door command.
And last but not least, we have the mode. This is where we get specific. We tell our watchman exactly what to look for. It's not enough to just say, watch the pin. We have to tell it the precise condition that triggers the alarm. Are we looking for the voltage to go from low to high, or from high to low, or something else?
And you've actually got a few options here, which is pretty cool. You can set the mode to rising, so it only triggers when the signal goes from low to high, or falling for the opposite. There's even low, which triggers constantly as long as the pin is held low. Before a push button, change is often perfect.
It triggers whenever the pin's value changes, either from high to low or low to high. That means it catches both the press and the release of the button.
All right, so we've got our attachInterrupt function all set up. We've written our tiny little ISR function to flip the red LED. And our main loop, it's just happily blinking the yellow LED, minding its own business. So let's upload this new code and see the magic happen.
And look at this comparison. It really tells the whole story. On the left, that's our old code. The main loop is all cluttered up with if-else statements for the button, plus that big blocking delay call. It's a mess. But now look at the code on the right. The void loop is so clean. All it's doing is blinking the yellow LED. The button logic has been moved out completely, handled automatically and in the background by the interrupt. It's just elegant. And the result? It is flawless. I mean, zero lag. You press the button, the red LED is instantly on. You let go, it's instantly off. And all the while, that yellow LED is just blinking away, completely unaffected. That is what true hardware-level multitasking feels like. So why is this such a big deal? Why does this matter? Because interrupts are, fundamentally, how you build complex and efficient projects. They let your little microcontroller truly multitask. They're absolutely essential for anything that needs to be responsive in real time. Think about emergency stop buttons or reading a fast-changing sensor. Plus, they just make your main code so much cleaner and easier to manage. This isn't just a trick, it's a foundational concept.
And that really gets you thinking, doesn't it? Once you understand interrupts, you start seeing them everywhere. They're in your microwave oven, waiting for you to press a button. They're in your car safety systems. They're working silently all around us, all the time. So here's a question for you. What's another device in your own home, something you use every day, that you think completely relies on this kind of instant reaction to do its job? Give it some thought. Thanks so much for joining me.